So this is our Pearson product moment, what's this? Pearson product moment correlation coefficient. So we have the value of R, and again, for now, the intention of this R value is to interpret, right, what it means, right? Once again, in here, we're talking about correlation, not causation, right? Once again, a causation only happens, okay, which means that the explanatory variable is actually the one that causes either an increase or decrease in the response variable. That only happens if you do an experimental study, all right? In short, you do an experiment, you manipulate the explanatory variable, whether that be introducing a medication, changing the dosage, introducing like a sugar pill, what we call a placebo, right? As compared to maybe half a dose and maybe a full dose of whatever medication it is, then that can only, those are the studies that can only lead to, a cause-effect study, right? If it's explanatory, if it's experiment, right? However, if it's not an experiment, then all we can say that there exists, right? There's a possibility that there exists a correlation, either a positive correlation or a negative correlation. Between what? The explanatory variable and the response variables. In here, it is important to know which one is independent, the explanatory variable, and which one depends on that, right? And that is the response variable, right? And there are two different scenarios for such. If there actually exists a strong correlation, right? Or sometimes a perfect correlation, right? So a negative correlation means that an increase in the explanatory variable leads to what? A decrease in the response variable, okay? Again, we're talking about linear correlation, right? Because there are some cases where the correlation is quadratic or exponential, but in this case, we're talking about linear correlation, right? However, if the increase in an explanatory variable will lead to an increase in the response variable as well, right? So we are expecting the slope to be positive, right? If you talk about the slope, right? That's the average rate of change. And the R is also going to be positive, right? So what is the boundary for R? So your R can only go from -1, that's a negatively perfect correlation, to +1, which is a perfect positive correlation, right? Now, how do you know if there's an actual positive or negative correlation, or there's no linear relationship at all? Well, it depends on the critical value of R. There's a table for such that we're going to see later, and we're going to base it from there. And that critical value depends on the sample size as well. Good, so we're going to see later those cases. So let's talk about this particular problem in here and how to solve this problem for, what is this? Weight of a car versus miles per gallon. So, we are concerned in some case of like how fuel efficient our cars are, especially with like, gas prices, right? Definitely, it's not a problem if it's gonna be an electric car, which is kind of like a thing that's happening right now as well, right? But in terms of like how heavy the car is and how fuel efficient it will be based from the, the weight of the car, we'll see in here, right? Let's read this problem first. Andrew, go ahead, please. Oops.
An engineer wants to determine how the weight of a car affects gas mileage. The following data represents the weight of various domestic cars and their gas mileages in the city for the 2015 model year.
Thank you, right? So these are the cars and their corresponding miles per gallon, all right? So again, one of the factors that does affect fuel efficiency is the, miles per gallon consumption. But again, there are some other factors affecting that, like what else? Tire pressure, and how good the age of the car as well, and how good the engine is. So those who are like experts in automotive mechanics, I'm pretty sure you are more familiar with these different factors other than miles per gallon. But we can say that it might be a consideration, right? The weight might be consideration for the miles. Anyway, so let's read in here. Letter A. Let's read that one in here. 3. Determining
which variable is like the likely explanatory variable and which, sorry, I can't read that. Sorry.
Yeah, likely the response variable. Thank you. Right. Again, we have our practice exercise in there. So look at the practice exercise. It should say number 37. Are we good, guys? All right. Anyway, going back in here. So what do you think is the independent variable? And what do you think is the response variable? Right? Again, this is not the cause-effect study. This is more of which one explains the other one. Okay? So what do you think, guys? Which one is the explanatory variable and which one is the response variable? Okay?
The response variable is the miles per gallon.
Very good, right? So in here, we can say that this one is the response variable, right? The miles per gallon.
And the explanatory variable could be the weight.
The weight, definitely, is your, what we call explanatory variable, right? Let's call it X bar, all right? Explanatory variable. Are we good, guys, with what we did? So again, that's always the first case for establishing a possible correlation. Which one explains the other one, all right? Again, I would always emphasize this is not a cause-effect, right? But more of like correlation. Not causation, but correlation, okay? Let's read letter B, okay? Let's read letter B in here. Mason, go ahead, please.
Draw a scatter diagram of the data.
All right, so how do you draw a scatter diagram of the data in here? So again, we're gonna use either Desmos, where you can plug in all of the values in there, or you can also use your StatCrunch. All right, so ready, guys? Let's do our StatCrunch for now. So we're going here. We're going to our oops. So let's see that data set. Let's go to StatCrunch. Here it is. Let's go to data set from our textbook. Okay. We're trying to consider scatter plot, right? Okay, so, or scatter diagram. So we're gonna go to chapter 4, all right? That's what number again is that one?
37.
37?
Yes, sir.
Thank you. So 4137, let's click in there. 4137. So as you may notice, that's our data set. Okay. So once again, in Desmos, you do the same. You just copy that one. Okay. If you want to do that one. Anyway, so let's go to where? Let's go to graph. Again, we are doing scatter diagram, all right, or scatter plot. And then after this, we're gonna go to what? Again, what are we going to get? Scatter plot. Get it? So again, graph, scatter plot. And the X is always your explanatory variable, right? Whatever your explanatory variable is, that is your X. So in here, what is that?
Weight.
The weight in pounds. Very good, thank you. The Y variable is always gonna be the response variable, okay? Which is in here, the miles per gallon. Again, as always, as you may notice in here, for Pearson product moment correlation, all variables that we're looking into are quantitative in nature, all right? You cannot do a Pearson product moment correlation for qualitative data, right? Always gonna be that both explanatory and response are quantitative in nature, right? Either discrete or continuous, but typically continuous. Get it? Anyway, let's go back in here. We got that. You can put in the labels if you want to, all right? So in here, we can click on points. There we go, right? Okay, x-axis. X-axis, what is that again? What is our x-axis? That's the weight, right? Weight of the car in pounds. Oops. Okay, if you want to be clear with that. And this one is the mpg, miles per gallon. Get it? Okay, and then if you want to put the title, it's better to actually put in the title, scatter plot. Oh, what's this? Car weight and miles per gallon, right? So at least we have a label for that, okay? And then compute. All right, so here it is. That is our scatter plot or scatter diagram for weight as in pounds as the explanatory variable, and mpg, that's miles per gallon, as the response variable, right? Now, just by looking at it, can we have an assumption already of, are we looking into a what? A negative association, a positive association, or no association at all? It's more of a negative, right? Not too strong of a negative correlation, but we can see that already. Are we good? Right? Because as you may notice, as your weight goes more, the mpg kind of gets lesser and lesser, right? So, but again, it's not too strong, right? Because as you may notice, the data points are not clustered. Get it? Okay? They don't get a really good linear trend anyways. Get it, guys? Okay. Let's go back. Where's that problem? Okay, here it is. So we are done with the scatter diagram. Let's talk about letter C. All right, let's read letter C in here. Kalina, go ahead, please. Compute the number 37, letter C. Thank you, right? So let's compute now the linear correlation coefficient between the explanatory variable, weight of a car, and miles per gallon, which is the miles per gallon, which is the response variable. Get it? Okay, so let's go back to our StatCrunch and let's do this. Okay, so this now we're gonna compute for the actual R. Okay, so how do we do this? So here it is, okay? Let's go to statistics, right? Let's go to stat, okay? After going to stat, we're gonna go to summary statistics, okay? So again, we're going to summary statistics. And then we're gonna select what? Correlation. Are we good? Okay, so again, we're gonna select correlation. So here it is. Now after that, what do we do? Okay. Let's go get this one in here, this two, okay? Weight and miles per gallon, right? Yeah, and basically that's it. Let's see. Okay, let's compute. Let's do the computation. What did it say?
Negative.
Negative 0.84, right? You see a negative 0.84 in there. The correlation between weight and miles per gallon is negative 0.84, right? So there we go. We can put in here like such. R is equal to, or approximately equal to, negative 0.84. Okay, so again, what did we do? We went to stats. We went to summary statistics. We go get the correlation. all right, and choose those two variables. Are we good, guys, with what we did? Okay, so again, that's our correlation between those two, weight and miles per gallon, negative 0.84, okay? Going back, so which basically confirms, okay, so that's negative 0.842, that basically confirms that our relationship between weight and miles per gallon is what? Negative relationship. Are we good? All right. Next one in here. Let's read letter D, right? Let's read letter D. JC, let's read that one. Letter D here. Does a
relation exists between the weight of a car and its miles per gallon in the city?
So, is there a linear relationship that exists between weight and MPG? We said what? Yes, there is, right? Okay, it's negative 0.84, which means that's a negative correlation. Are we good, guys? Questions with that one? Okay, next one in here. Let's read letter, what's this? E. Let's read letter E for such, okay? Juliana, let's go ahead. Letter E. Suppose that we add a Ford Fusion Hybrid.
Suppose that we add the Ford Fusion Hybrid to that. A Fusion Hybrid weighs 3,639 pounds and gets 44 miles per gallon. We draw the scatter diagram with unit information. What do you make?
Thank you, right? So we're gonna add that Fusion Hybrid. It says what? 3639.44. Get it? So let's put that one in there. 3639.44. So let's do that one. Go back in here and add one more. 3639 and then put in here 44. All right. And again, this is what? Ford Fusion Hybrid. Oops. Are we good? Right? Oh, double B. Good, yeah. Ford Fusion Hybrid, it says 3639 and 44 miles per gallon. Get it, guys? Now let's compare. How does it look like in terms of the scatter diagram? Okay, so let's go to scatter diagram this time. Oops, okay. Graph, scatter plot. Let's go back in here, click weight. Back here, click miles per gallon. All right. And let's just compare that one. I'm just gonna click on compute and see what happened, okay? Okay, so let's look in here. Let's okay, so this one is with a Ford Fusion. Now what do we notice with the Ford Fusion here? Hybrid, by the way. So the Ford Fusion Hybrid is in here, right? Okay. It doesn't follow the trend. Are we good? Right? It's up there because, as you may notice, in terms of weight, it's basically within that frame, right? However, in terms of miles per gallon, it's way up in there. Again, consider this is what? A hybrid, right? So when you say a hybrid, anyone who's experts with, well, not really experts, but you know, typically when you say hybrid, your miles per gallon is way up in there. We good? Why? Because it's a combination of what? Anyone? Gas and the electric, right? Okay, so you know they definitely up the miles per gallon or fuel efficiency. Get it? Okay. So let us now consider the R from here, right? So if we consider the R from here, what do we do? Let's go to stat once again. Summary stats. Let's see the correlation with the hybrid and see how it affects the data set, right? So what do we notice in here? What's the R now? Anyone who can tell us? It's negative 0.33, right? So when you say negative 0.33, it's almost zero already, right? It's almost near zero already, right? So in here, we can say that there might not be any correlation at all if we include that hybrid type of car. Are we good? Right? So with that being said, what can you say about the data set? Should we include the Ford Fusion Hybrid with all the other data sets? No, right? No. Why? Because honestly, its engine is different from the rest of them, right? Because the hybrid engine has the combination of the electric and the gas-powered engines as well. Are we good? Right? So definitely that doesn't go with that group. Any questions? Questions, guys? Get it? Okay. So with that being said, going back, what's our next question for that? Letter F, we have recomputed that one is negative 0.33, so a weak correlation already, right? Still negative, but a weak correlation, almost zero, right? And why does this observation not follow the pattern of the data? Again, what's our reasoning a while ago? What's a hybrid car? Braden?
Electric.
It's electric and gas powered, right? So definitely the engine of that one is a big factor on the miles per gallon. But for the rest, it's basically mostly the weight. Are we good? Right? Because typically the rest has like either a V6 or what other engines do you usually have? V8, V6 or V8, right? But the other one is a hybrid, so, and Fusion as well. Is it to say Fusion, Ford Fusion hybrid, right? Okay, so it's basically different in terms of the engine itself. Are we clear? Right. So once again, summary, here it is, okay? So perfectly negative correlation, -1, all right? Perfectly positive correlation, R equals 1, and R equals 0 is in there. Are we good, guys? And typically, it would always give us some data about critical value for R, right? So if we go back in here and see, okay. If we go here and just put it here, right? R critical values. So we are gonna see some tables that has some critical values as well. And again, as we said a while ago, the critical values will depend on the sample size, right? So what's the sample size a while ago, guys? In here, what's the sample size? 11 with a Ford Fusion hybrid, right? Thank you, Mason. So you're gonna look into the table. This is basically a table of R critical values, or RCVs in short. And then you're gonna look at N equals what? 11, right? Or if there are 10 without the Ford Fusion hybrid a while ago, then you look at 10 as a sample size, and that's your N value, right? And you will compare now, right? So here it is, okay? If your computed R is more than the critical value, right? More than the critical value, then we can say that yes, we have established a positive correlation, right? However, you just get the negative value of that. So if it's lower or more negative than that critical value, then we can establish that there is a negative association. Because the question in here is, what is the basis for saying that, well, there's no actual linear correlation as compared to there is an actual correlation? Well, there should be a critical value that sets a boundary between establishing if there's none or if there is. Are we good? So that's basically that, right? You are basically comparing whatever your R is from that critical value, right? In a table, you would always look into the positive value, but definitely if it's a negative correlation, you just get its, sign, change it, and compare it from there, right? So either it's more than the critical value or more negative than the negative critical value, then you would establish that yes, there exists a positive or a negative correlation, right? Other than that, then you can say that there's either a moderate correlation or no linear relation at all. Who knows? It might be like an exponential or a quadratic correlation, actually. Are we good, guys? Get it? All right. Thank you. We can